Hello everyone, welcome back to the channel. In this video we are going to be doing a how-to video on how I made something for Halloween last year for my display, but have recently improved upon it this year. And that is this right here. So you all might be asking yourself, what exactly is this thing? Well, this is actually a multi-prop remote controller. It's a wireless device that I'm able to use a little key fob like this one right here. It has 4 buttons on it, and you can get these in different amounts of channels as well. I think there's like 16 channels potentially on some, but I went with the 4 channels. And what it does is very similar to what the Spirit Halloween wireless remote controller does, and that is just sends a little signal to an animatronic to activate it. Now, like I said before, I had these last year, but I have actually improved on the design, and that is by adding like an actual box encasement that I have to protect the electrical components that are inside here. And what's nice about these ones is that there are little plugs here to open up, and you can use these to connect, so you don't have to coil up a wire around this thing, or 4 sets of wires in that fact. You can just unplug them when you're done at the end of the season. So this plug right here would plug into a wire that would act as the try-me plug, and that would trigger an animatronic. So you can just unplug it, close it off at the end of the year, and not worry about it. Even if you only have 2 or 3 props that you want to use, and you don't have a 4th one, you can just close it up so it doesn't get wet or corroded. Now, my overall plan with these is to use them outside and leave them outside and not really have to worry about getting them wet or corroding. So one thing I haven't done yet is actually making a seal. This lid is able to be unscrewed off, and then you can get into the internals. And I want to show you how I put one of these together in this video. Let's go downstairs and assemble one of these multi-prop controllers. Alright, so these are all of the components that I need to assemble one of these things. And I just want to give you a quick run through. So this is, again, the box. This is what it looks like without the lid on it. And as you can see, there's a couple predetermined screw holes for the box to go on. And then you have the 4 openings for the main plugs right here. And then as well as the little 2 openings for the main power wires. So if I didn't say it in the previous video, this is all being planned to be ran on a 12-volt system that I'm working on. And these are the connectors that I found, and I found these from a guy called Van Oaks Props. This is something that he found online, and they are like waterproof connectors. So basically what happens is you just plug these together here, and there's a certain way to put them on, so you can't really put them on backwards or anything. And then you just take this little cap and thread it on, so it's a nice tight waterproof connection. And there's actually a seal on this one. You can see the red seal right here. The red seal right here, so this shows some waterproofing. And it's not like, I'm not going to submerge these underwater. I just want to make sure that these things can stay outside. So the next thing right here is the actual plug that you would plug in the try-me jack to. And I just pre-wired these with some little jumper wires so they can just go into the board with no problem. And yeah, these are pretty simple. You can buy these. I actually got these off of AliExpress, and these come with this side and as well as the male end here. And the thing that is important to note with this is that this is not the same plug as like a normal adapter plug. So that is something I didn't really realize, but for what my purposes of using it are, it's not that big of a deal. And the thing with this is it doesn't matter really which kind of plug you use. Personally, I would want something with a threaded back so this can get screwed and mounted to the box. But it's not necessary. You can have something with wires that just come out. And there's many different ways of doing this. I actually originally used this thing as my first attempt. And this is just like a Tupperware container. There's some holes for the wires to come out. Very primitive stuff here. And this one came with a battery box because I did not yet have the 12-volt system I'm talking about. So this is just a 9-volt battery pack that is just hot glued to the side here, and you can pop this open here, and then there's your battery inside. So this is the first rendition of it, but I have since obtained a 3D printer, and I made a much more professional professional looking box. It even has some mounts for you to mount it to like a piece of wood and like screw it in so it can just sit like perpendicular to the ground here and just have the wires come right out the bottom. So I'm pretty happy with this design. I'm sure there's going to be improvements and stuff in the future. So basically that's all the components here. Nothing too crazy, nothing really intensive. Pretty simple stuff with the parts, and I'm going to go through and showing you how I put one together. It's pretty self-explanatory, to be honest. Maybe I should show you the actual control here. So this is the control here, and it's actually meant for garage door openers. Now you might notice that there's actually four boxes right here. These are the relays, and each relay has 3 outputs, and you can see the screws are the mounts. So we're only going to be using 2 of the 3 outputs, and I'll show you that when I put it all together here. There are 2 pins right here that are for power in, so that is where we're going to be hooking up the 12 volts to, V negative and V positive. And then there's the other set of relays out here, so there's 4 in total, and that is basically all you need to know. There's different settings that you can do for this thing that make it do different things, but I just have it on like the default setting the way it comes, and these go for about like $16 I think when I first purchased this one last year. They might have gone up, they might have gone down, I don't know. But another thing to think about is making sure that the frequencies that they run at. Now this one, I'm not sure the exact frequency that this one's running at, but there was 2 different types. But you can also get lucky because I think the frequency was like 433 megahertz or something like that. But then you can get into the decimal, so it's kind of like a luck of the draw of which one you can get. So you could potentially like buy a bunch of the same and not have to worry about it. So what I did is I bought one of the types of channels, and then I bought a different channel, so I don't really have to worry about that. But if you want to experiment, you can always return it if it triggers the same thing, because that's the problem with the Spirit Halloween ones. You can't buy 10 of the Spirit Halloween remote triggers without the A button triggering all of the A relay switches. So that's the problem with that. So that's why I've gone to this design, because I can make it different, but depending on which unit I buy. Without further ado, let's get started. Now I've actually pre-drilled out some of these holes here because the 3D printer specs and stuff is a little different from everything else in terms of the real life scenario. I could make them bigger, but I just find it's easier just to drill them out with a drill bit. And now the screws go in very nicely. These are the screws that actually come with the original relay box, and that's what these holes are designed for. Basically, I basically just took one of these out and designed it in the online software. And the software that I used was the Fusion 360, and I found that that actually is very close to, I usually used to use the Autodesk Inventor when I was in high school, but the Fusion 360 is very similar in just practice of how it works and stuff. So that's how I made these, and I'm very happy with how they turned out and stuff. It's kind of easy to maneuver if you're aware with the Inventor style. It's just formatting's a little different and stuff. So there is the relay mounted in. Now what we're going to do is mount the little female plugs that go in these holes right here. So here is the first one that I'm working on here. It has longer leads to reach to a farther end of one of the relay modules. And we're just going to put the little seal over it first. And then we are going to put the plug through the box here. And it just is a pretty nice snug fit. And then we will take our lock washer and our small nut right here and thread these on. It might be difficult to get a wrench in here, so what I actually use is a pair of needle nose pliers to pinch the nut to turn it. And you really want to go from this one first and then continue your way down, or else it'll be very difficult to get this one tightened because the other one will be blocking the needle nose pliers to be able to get in there and tighten it down. Okay, so I got all 4 of the plugs in, and they're screwed in and mounted to the wall here. Before we plug in these wires to the relays, let's plug in our actual power cords. Now these 2 power cords are actually going to go through these 2 holes right here, and what these 2 cords instead of 1 are doing is that they are going to be able to supply power inwards, and then 1 cord will be used for giving power outwards. in a way of like daisy chaining almost, but it's not really like real daisy chaining because you can disconnect this and it would still like function properly. So this is just my way of doing it, and everyone has their own way of possibly working on this stuff. This is just the way I found might work best for me. So we're going to take both of these cords, fish them through the holes, and then we are going to tie the matching colors together and then put them into slots. So I plugged these into the respective ports, red to positive and black to negative. You might want to hot glue this into place. It might not be a bad idea, especially from the inside. I will do that eventually, just not right now. Next, we're going to want to plug in our tri-me cord connectors into each relay. So the next thing that we're going to want to do is we're going to want to test and figure out which connections we want to plug our tri-me wires in. Now, an easy way to do that is with a multimeter, and this is how I'm doing mine. So first, I'm going to set my multimeter to be on to resistance here, and we are going to want to see which way resistance is open and closed. So I have my two leads on the NO pin and the COM pin, okay? And what I'm going to do is press the button, see what happens. All right, so that's what you want. That's basically what a tri-me button does right there. You press the button and the resistance is close to zero. Right now there's infinite resistance, I believe, because, well, they're simply not connected right now. Once you click it, there's very low resistance. Now, you can also see if you put it on the COM pin and the NC pin here, you'll see that the lead is saying that the resistance is at zero. There's zero resistance right now. When you press the button here, it goes back to infinite resistance. And the thing that is with that is, I don't know if that's a good thing, if to have constant resistance or constant open resistance on the animatronic. So for my purposes, I am going to go with the way it's set up right now, where you press the button and then the resistance is dropped down to zero, like this. That's what I'm going to go with, because I think that's typically how a tri-me button works, and that's just, I'm just trying to be as safe as I can when it comes to working with the animatronics. I don't want to wreck my animatronics. Another thing to take note on is voltage. I don't think it's a good idea to really be running voltage into your tri-me port, so we're going to take our multimeter, go to DC voltage. I have it on 5 volts max right now, and we are going to test those pins to see if when I click the button, is there any voltage output in those pins. So I have my pins this one way with the polarity. We're going to press the button and see what happens. No voltage output. We're going to swap the leads just to make sure that we go both ways, to make sure that we're doing it the right way at least once. No change in voltage. So that's what we want to see. Now we know that there isn't any voltage being ran through these tri-me pins. Okay, so now we have each of the tri-me pins connected into the respective ports, and you can do it however way you want. Just remember whenever you press the output buttons. Now let's just double check our work here. Let's put these pins back into their respective areas just to make sure that once again we have no voltage, and making sure the resistance output setting is like the right way. And all right, we have it set up the proper way. So now that is basically the end result of our little project here. Like I said, for power, this is being outputted by a 12 volt 1 amp adapter. That's what I'm currently running right now, and it does a good job. When it comes to doubling up and using multiple things, I don't know if 1 amp is sufficient enough. I would believe the 1 amp is sufficient for only one here, because this one thing was able to work off of a 9 volt battery alone. So I'm using a 1 amp power supply. You just want to make sure you have enough amps to supply, but you want to match the voltage. So like I said, this thing was able to run on a 9 volt, but I believe from Amazon, I think that's where I got it from, it said these are meant for 12 volts. But yeah, so that is basically a success. Now let's take it upstairs and test it on one of our animatronics. Okay, so I have my little box here on the floor, plugged in to power, ready to go. We're gonna flip up let's flip up this one right here for ease of use. And we're gonna use the Reaper of Souls today. So here is the end plug that I did. I made up just one extension cord for a Trimey. So this goes into his Trimey jack, as you can see over there. And we're just gonna plug this into our box and hopefully everything should work. So let's just plug it in. There we go. Now I'm going to plug him in and we're going to see if it works. Okay, so it's all plugged in, ready to go here. It's all wired into the Reaper. He is on button A, so let's see if it works.
May the demons of the underworld have mercy on your soul.
So it is a success. I have currently made only 2 of these things. I still have to make a lid for this one. But I do plan on expanding this to be more interworking. I've come up with ideas with using Arduinos, and I will share those with you when they all come into reality. But this is where I'm going to end this video. I hope this helps you guys out in making your own little relay devices to be able to operate animatronics that are maybe not having the best of sensors like the older stuff. And you can trigger them on command whenever people walk by. And it's just something that I really is a pet peeve of mine, is props that just don't have good sensors and you have to like wave your hand right in front of it for it to activate. I don't like that, so this is my solution to it. Like I said, we will be expanding on these ideas in the future, but this is where I'm going to stop right now. Thank you all so much for watching, and I will see you all in the next video.